Hello, all. Welcome. I'm gonna wait a minute because it looks like there are people still coming in and being admitted.
I can
We'll
click the
get
button.
started here in just another minute. Those of you on here, if you want to mute for the moment, I hear some background noise. I don't know.
Um, I'll mute myself.
All right, well, why don't we get started? I think we'll just to let you know, we are recording the session and we'll make it available for folks who are not able to attend today, but we thank you for joining us to hear about the new Masters in Quantum Science and Engineering that we are launching this coming year. And so, just to introduce myself, I am Jessica Rosenberg. I'm a professor in the Department of Physics and Astronomy, as well as Director of Education for our Quantum Science and Engineering Center. Chris?
And I'm Chris Guy. I'm a professor in the Electronic Computer Engineering Department. Michael?
Michael Jarrett, assistant professor in math and CS.
All right. So just to kind of give you, many of you are here, you're interested in quantum science and engineering, so you may know a little bit about it, but just to sort of situate us as where we are and why we're doing this now, uh, we are at what a lot of people are now calling the second quantum revolution. As a physicist, we think about the first quantum revolution really starting when we discovered some of the laws of quantum mechanics and then building the bulk technologies that came out of that. The laser, the transistor, which is at the heart of all of our classical computing hardware, are some of the key technologies that came out of that. We are now in a position to manipulate the universe and the world at the smallest scales in new and different ways. And there are a lot of technologies that are emerging around that. And we think now is a really good time to try to capitalize on it. So, what is this? Why now? Um, Part of that is that this is a growing industry. The market is proposed or thought to be growing to greater than $20 billion by 2030. Um, and even more beyond that. It's expanding rapidly at this point. The jobs across the US, but also locally in Northern Virginia are growing. In fact, we just did a couple of surveys for jobs and the few months between when we did it, but there was a huge expansion in the number that we identified in that list quantum as a skill that's desired. And when we went and talked to folks in industry to try to understand what it is they want out of employees, at least at this point, and thinking about those employees at the master's level in particular, one of the things that they told us was that having an understanding of a STEM discipline with quantum skills layered on top of that was really what they want to see. So we've designed our program to try to address that need that industry is seeing. I will also say that this is building on some other things happening locally in quantum. We're in the process of building, we're calling the Commonwealth Quantum Hub, which is going to bring a lot of quantum infrastructure to George Mason, including quantum hardware training labs, industry collaborations, and a developing ecosystem in this region. More companies, more jobs coming as well to the area. So this really is, we think, the next revolution in computing, sensing, and communications, right? Because it hits all three of those areas. And so we want to capitalize on that and help students be prepared for those areas and those jobs. So who is this program for? We're really targeting students who are interested in building cross-disciplinary STEM and quantum expertise. What we mean by that is, if you're coming out of any of the science disciplines, and science and math disciplines, whether it be physics, biology, chemistry, mathematics, as well as engineering and computing, and have an interest in quantum, bringing those things together and thinking about how you prepare that and what industry's looking for. So we do include a component that's on research or an industry internship type experience, because we think that's an important component of this program as well. We'll note that the program is currently focused on computing and algorithms. We expect hardware courses to be added in the near future, and ultimately also probably not too far off hardware concentration, but that is currently not the the focus of the program. So, this is open to students with bachelor's in a STEM discipline, whatever that STEM discipline might be. Those currently enrolled in bachelor's at Mason in the College of Science, we have a bachelor's accelerated master's program through the College of Science, and within the next year, probably in a year from now, we will have one through the College of Engineering and Computing, but through that college, it's not currently in place. And then current STEM professionals looking to build their further quantum knowledge. So it's appropriate in that space as well. What are the enrollment expectations? You sort of figure this is an important question. As we said, a bachelor's in STEM disciplines or being in the process of getting a bachelor's in those disciplines, or sort of the equivalent of sort of STEM coursework at the advanced undergraduate level in a STEM discipline, even if the degree is actually not in STEM. While advanced math, programming, and physics are not required for the program, your willingness and readiness to take courses that will provide the background in those areas is a must. So we actually, and I'll point to this as we get to the course structure, have courses to hopefully prepare students who maybe don't have all of the math or all of the programming for our courses. You obviously have to be ready to kind of take those math and programming courses as you go. So currently I say all of the core courses and almost all of the elective courses are in person. So just to note, this is an in-person program. It is not a virtual program. I put the tuition rates up here just so that you have them. There is a significant advising component to help support this program, to help decide which fundamental courses are needed, select electives, identify research capstones, and approve that research capstone. And I'll talk about what those courses are now. So this is a 30 to 33 credit degree program. It consists of foundational electives, core courses, and then additional electives. So sort of three categories of programs, of courses. The foundational electives are two. One is mathematical foundations of quantum science and engineering. The other is programming foundations of quantum science and engineering. If you are proficient in both of these areas, you do not have to take either of them. But if you need some of the background in either mathematics or programming, these courses are available to kind of prepare you for the rest of the coursework. And advising is part of figuring out, right, where you belong. Now, if you have to take both of these courses to prepare for the rest of the coursework, you will be in a 33 credit program, because only 3 of those credits can officially count towards the degree. So you'll be taking an additional 3 credits to complete the program. So there are 5 core courses, 15 credits, an introductory course, an algorithms course, an applications of quantum technology course, this quantum computing system design, and then this master's research project. And that research project can either be done as research at the university or as an internship with industry. So both of those options are possible and supported within the program. In addition, there are 12 to 15 credits of electives as part of the program, and this is where you have the opportunity to dig into computing and its application to your STEM discipline to go alongside of the quantum courses that we have here. So there are two types of electives that are part of this. At least two courses from these advanced quantum electives, right? Classical and quantum information theory, quantum algorithms, error correction, as well as the master's thesis. And this is where, as hardware courses are added, we expect some of those will actually fall under these quantum electives as well, but they are not here at the moment. And then specialized electives for the remaining credits. And you see, this is just a handful, a sampling of those courses. There are actually more that fall within the specialized electives, which are really computing as applied to one of the STEM disciplines. Now, this year is going to be a bit unusual in terms of the way the program goes forward because we're just getting it launched and just recently got approval for the program. In fact, after all of the fall courses were assigned. So what we have available in the fall is a little bit more limited than we expect to in the future. Our quantum algorithms course is being offered, and we think our ideas in quantum science and technology course will be offered, but that is yet to be confirmed, as well as several of the electives that will be offered, which I'll get to in a moment. So you can take some of the elective courses in the fall, but there are fewer of the core courses that are going to be available. For spring 2027, we have a lot more of the core courses available. It's sort of the way we would expect students to kind of start in this program will be much easier to do starting in the spring with the Ideas in Quantum Science and Technology course, Mathematical Foundations, Programming Foundations, and Quantum Computing System Design all being offered, as well as some of the electives. Those electives for fall 2026, just so that you can see what those are. There are, as we said, a handful of them available across some of the departments. So numerical methods in bioinformatics, computational physics, analysis of algorithms, molecular dynamics modeling, operations research, numerical methods, applied cryptography, and remote sensing, right? So across multiple departments, we have some of those available. And then getting into academic year 2027-2028, where we expect things to look more like what it will look like going forward, right? In a typical year, this is what the course availability will be likely to look like. Those core courses in the fall will be that ideas course, as well as the two foundations courses, classical and quantum information theory, applications of quantum technology, advanced quantum algorithms, and then in spring, quantum algorithms, quantum computing system design, error correction, and actually that research project will be available sort of when students are ready to take it. So currently it's assigned for spring 2028 because we don't necessarily expect students signing up for it before then, but there's some flexibility in that as well. All right, so moving on to applications. So applications right now are a little more complicated than we had hoped getting this launched. For the standard application process will launch for spring 27 application admissions. So it will be available so that you can apply at this link, and we'll send out, I think, a copy of these slides to our mailing list. If you signed up for the session, we'll forward them along. So starting August 15th, the Quantum Science and Engineering Masters will be visible at this page for spring 2027 admissions. If you're chomping at the bit and really want to start earlier, we can't take formal applications for fall 2026, even though the program exists. However, you can sign up as a College of Science or College of Engineering and Computing non-degree student. The application deadline is August 15th for that, and earn up to 12 credits that you can transfer. Again, the link is here. I will note that the tuition rates that I showed do not apply to College of Engineering and Computing programs, so those are slightly different if you're applying through that path. We also strongly recommend that if you want to do this, that you contact one of us about which courses you're taking and make sure that your application looks good so that, you know, when you apply for the spring, we can see that you will be accepted into the program, but also that you're taking courses that will transfer into the program when the time comes. In addition, you know, please do contact us if you're interested in talking about what credits might transfer from either other MS programs at Mason or PhD students who may want to add the master's as a secondary program. There are forms to do all of these things. And so please do come talk to us if that's a path you want to consider. For those of you who are current undergraduates at Mason, we, as I said, currently have a Bachelor Accelerated Master's for students within the College of Science, and hopefully next year we'll have one for CEC students. If you're a cost student and want to apply for the Bachelor Accelerated Masters, we have the link to do this. At that link, please do fill out the Bachelor Accelerated Masters interest form. And the advantage of doing this as a Bachelor Accelerated Masters is that you can start taking some of those graduate courses sooner, and you can take them at the undergraduate rates, which is a nice advantage, and the application fee to the program will be waived. Because you can't apply until spring, we're going to have a waiver for one of the graduate courses that can be transferred into the BAM if you take it this fall. So again, please do come talk to us if that's something that you're looking into doing so that we can make that happen. And with that, I said a whole bunch of things, and I'm sure there are lots of questions, and I will pause there and see what we've got. I don't know if we've had any in the chat. I should have said, please feel free to throw them into the chat, or you can take yourself off mic and ask as well. There are really no questions. I find that hard to believe.
I can open up for a question if my mic isn't completely blasted by the wind.
No, we're good.
We have
Okay,
a couple of, oh, sorry, go ahead.
Yeah, so I'm an engineer transferring in. I'm actually coming on board as a term faculty in the mechanical engineering department starting in the fall.
Okay.
But I do a lot of consulting work for quantum sensing at the moment, and was kind of curious the timeline to add on some of the more mechanically oriented elements like all the fabrication that goes into quantum computing. I work a lot with quantum computing companies, and I see that there's just a really strong need from when I'm talking to the companies that I work with for core engineers to come into the field. So I'm getting the same insight as you, but it is a lot of it's on the mechanical side. So I'd just love to hear sort of the timeline for that.
Sure. So what I will say, and absolutely, is part of this is about facilities. We just got or are in the process of acquiring some quantum optics equipment. So that lab is going to get set up, I believe, this summer, which means that starting a course through that certainly by next spring, by spring 27, will almost certainly happen. We're hoping also to get some cryogenics equipment if that comes through soon, which is dependent on congressional budgets. That will also get set up and started, right? So there are these pieces with the hardware that mostly it's about facilities and getting them set up and getting the courses online. It is looking like we are going to be actually setting those up. Things are coming through in ways that we actually thought would take longer when we started preparing this program than they are. So I would say in the next year and a half, we're hoping some of those courses are coming online, but we'd love collaboration from people interested in this. So come talk to us. We'd love to get you involved. Other questions?
We have one in chat. Jessica, could you go back to the slide for the BAM application and just one more time run through? Somebody missed how the application is they wanted to know how soon they could get started. Sorry.
Yeah. So the answer at some level is right away. The first step is to fill out that BAM application interest form. The second is, and Jen or Melissa, correct me if I'm wrong, I believe it is 60 credits that you have to have before you can actually apply into the Bachelor Accelerated Master's program. So if you already have those 60 credits that you have taken, you can start right away. Unfortunately, it's a little bit of a slow start this fall, which is one of those graduate credits, but come talk to us about which one that is, and that will get you started. And as soon as that application is live in August, you can apply and start taking them many more of them starting in the spring. But if you have room for one graduate credit this fall, you can get started with that. Hopefully that answers the question.
And Dr. Rosenberg, for students wise, that applies to COS students at this time, right?
Correct. That is unfortunately only applicable to the COS students at this time. We don't currently have a Bachelor Accelerated Master's program through CEC. That will probably start. We're expecting it for fall 27. So stay posted, and we'll get that available and that information circulated as soon as we have it. Any other questions? If not, we'll stay on for a few minutes if people want to linger and ask questions, but that's what we've got. Thank you for coming. We hope we'll see you as part of the program for those of you who are interested. And any of you who are still here, if you have questions and want to chime in.
Jessica, I have a
That's
question.
a good question. Oh, sorry.
No, go ahead, please do.
So we're talking over each other. I'm going to read the one in chat, and then we'll save you for next. Is that? So there was a chat from there's a question in chat from Joshua. So if the CEC BAM pathway isn't available until later on, is a non-degree application the only way to start a credit for this master's in fall 2026? So he's basically asking, okay, so you're in CEC, you want to do BAM, but it's not. What do we do?
Right. And the unfortunate part of that is, yes, that is the only way that I know of to, I think, Chris, if you have another answer, chime in, to do it as a CEC student. Unfortunately, that doesn't give you the advantages of the BAM, which is those undergraduate rates. So
Can I also caution the non-degree thing for current GMU students? Because if they apply as a non-degree seeking student and they are a current Mason student, it will remove them from their current Mason status.
Oh,
So,
that's probably.
yeah, so they should probably contact their advisor and to see if there's an option for maybe reserve credit. If they are a
Okay.
current Mason student, if they're from outside of Mason, then what you said is correct.
Right. Okay. Yeah. So definitely talk to your advisor if you're a current student rather than going through that non-degree pathway. Thank you, Melissa. That's really helpful. Yeah, so we are partnering with companies in terms of computing time and hands-on experience, and we have some industry partners for those capstones so that students can get industry experience and internships. So we're hoping to have some places for students to go with that and get experience. So list of advisors to contact to get a sense of how to collaborate across departments. Adrian, what sort of collaboration are you wondering about?
Just in the sense of since it is more of an industry focused program that is bringing
Yeah.
STEM and quantum together, who are the advisors and what departments are they all coming from to build that sort of comprehensive STEM plus quantum knowledge that industry really is driving towards?
Yeah, so I mean, we're the three advisors for the program, but the Quantum Science and Engineering Center is supporting a lot of this effort, and we've got faculty in physics, chemistry, math, computer science, electrical and computer engineering, mechanical engineering, I believe. Pilgey's mechanical, right? There may be others. I may be missing some, but right. So we've got this broad group of faculty who are part of our center who are supporting this program and these efforts. We also just got awarded a Grand Challenge Initiative effort that's going to support the hiring of both an algorithms faculty and a quantum hardware faculty member who will contribute to this as well. I don't know if there are other questions.
I'm sure
I
some
don't see any
will-
others in the chat, so if anyone else has any, feel free to chime in.
And you should also just feel free to ask. You don't need to wait for chat or whatever.
Yeah, either way, or if you're more comfortable throwing it in the chat, that's fine too. And if there are no more, then we will thank you all for coming, and please be in touch if you have questions. If you're interested in enrolling, let us know, and we're excited to get this started. Oh, thank you, Jen, for dropping that in there. I think that's useful.